Here we are, question number 1 of exercise 12 then. Okay, question 1. Prove from first principles that the derivative of 10x squared is 20x. Okay, so they're saying this is f of x, and this is going to become f of dash x. Okay, so your first principles says that if you want the differentiation of the function, it will be equal to the limit of h tending to 0 divided fraction of f of x plus h, so just a little change in the x, okay, minus the previous value of x, okay, all divided by that little change. Okay, so as we start putting that in, okay, f of x is 10x squared, so we get the limit of h tending to 0 will be 10. Now instead of x, we've got x plus h squared minus 10x squared. That's the f of x, all divided by h. So as we start multiplying that out, okay, we end up with 10 times x squared plus 2hx plus h squared minus 10x squared, all divided by h, and so we end up with the limit of h to 0. Bring this up a bit. 10x squared plus 20hx plus 10h squared minus 10x squared, okay, all divided by h. And so as we tidy that up on the top there, we can see that 10x squared and the minus 10x squared cancel, leaving us with a 20hx minus 10h squared all over h, and that gives us cancelled by the h, we get 20x minus 10h. Okay, now because h is tending to 0, this term here, as h gets small, it becomes 0, because it would become 10 times 0, or very, very small. Okay, which means, so as, let's get this written up. So as h changes from large to small, it gets closer to 0, which means the minus 10h also becomes 0. So you are left with only 20x. Okay. So you're left with 20x, which was, of course, f dash of x. And that's what we were trying to prove, that 10x squared became 20x. Okay. Let's go on to number Question 2. I've lost my page. Point A has a coordinate of 1, 4. A is 1, 4. Okay, and it lies on the curve which has the expression y equals x cubed plus 3x. Okay, point B also is on the curve and has a x expression of this, which is 1 plus delta x, 1 plus a change in x. Okay, show that the gradient of the line segment AB is given by, show gradient of AB is, what is it, delta x squared plus 3 delta x plus 6. Okay, well, I think to begin with what I want to do is I want to find out what the y value is for this, and then we can use the standard gradient calculation on it to show the gradient. Okay, so taking that, I'm going to say that y is equal to 1 plus delta x cubed plus 3 times 1 plus delta x. Okay. Now, the gradient of AB is where if you have your two lines, you need to do the difference of the y's and the difference of the x's. So we've got the difference of the y's, so we're going to have 4 minus all of the above, 1 plus delta x cubed plus 3, 1 plus delta x, all divided by the difference of the x's, which is going to be 1 plus delta x for x2 minus 1, the x here. Okay, and so now hopefully as we put this all through, we're going to come up with something that looks a bit nicer than that and looks more like this that they're asking us to find here. Okay, so do I want to cube it out? I don't think I do. I think I am going to take it out separately. Let's have a look. So 4 minus, now this minus on here is around all of that. Okay, so I think I am going to have to square this out. So let's square this first. 1 plus 2 delta x plus delta x. Mouse. Delta x squared. Okay, and that all still needs to be multiplied by 1 plus delta x. Like so. Plus 3 plus 3 delta x. And that's still all divided by the 1 and the minus 1 cancel, delta x. Okay. Okay, so as we continue to multiply that out, Okay, we need to do the multiplying in here of 1 times that. So we end up with 1, we've still got the 4 minus, okay, and then we're going to end up with 1 plus 2 delta x plus delta x squared plus, okay, multiplying it all by delta x, so delta x plus 2 delta x squared plus delta x cubed. Okay, and we still got that plus 3 delta x on the end from the 3 times 1 plus delta x bracket, still all being divided by a delta x. Okay, so hopefully we can get some of this to cancel away for us. Okay, and then we're going to have to do a minus on it somewhere. Okay, so 2 delta x and delta x there is delta x squared, giving us 3 delta x. Okay, we're then going to also have a 2 delta x here with a 2 with a delta x here and a 3 delta x here. Okay, so that gave us 1, 2, 3, 6 delta x on that one, and then we've also got the 1 and the 3, which gives us a 4. So all in all, we end up with a delta x to the 4, no, to the 3, okay, plus 3 delta x squared plus 6 delta x plus 4, and then we've got still on the outside the 4 minus, and it still all needs to be divided by the delta x. Okay, so the minus gives us a minus on the outside here gives us a minus change, so that becomes a minus, that's a minus, that's a minus, and that's a minus, meaning that the 4 on the inside and the 4 on the outside now cancel. So we are left with in here delta x to the 3 minus 3 delta x squared minus 6 delta x, all to be cancelled by delta x, and that gives you a minus delta x squared minus 3 delta x minus 6. Okay, which all works except for we don't have the minus delta x, which is where I've made a mistake up here, and it should have been a minus on this one, which means we would have been carrying a minus all the way through on all those divisions, which would have left us with a positive, positive, positive as needed. Okay, and then they want us to deduce the gradient of the curve at point Well, given that the curve is equal to x cubed plus 3x, the dy by dx is 3x squared plus 3, and so when x equals, what is it, we're doing it at point A, aren't we? So when x equals 1, then dy by dx dx is equal to 3 times 1 squared plus 3, which is equal to 6. Okay, all done. Okay, then on to question 4 then. Not question 4, question 3, sorry. A curve is given by the equation y equals 3x squared plus 3 plus 1 over x squared, where x is greater than 0 at the point A, B, and C. On the curve, x is 1, 2, and 3 respectively. Find the gradient of the curve at A, B, and C. Okay, so dy by dx is going to be 6x, multiplying the 2 down to give you 3, dropping 2 by 1. The 3 disappears, and now this 1 over x can be considered to be x to the minus 2. So we end up with minus 2, multiplying it down, okay, and then x and minus 2 and minus 1 is minus 3. Now then, when x equals 1, dy by dx is going to be 6 times 1 minus 2 times 1 to the minus 3, which is, what does that give us? 1 over 1 minus 2, 6, 4, isn't it? Okay. Then when we have x is equal to 2, dy by dx is equal to 6 times 2. Okay. And then we get minus 2 over what would be 2 cubed. Okay, so we end up with 12 minus, what do we have? 2 over 8, 1 over 4, minus a quarter, so we must be on 11 and 3/4. Okay. And then finally, when x equals 3, dy by dx is equal to 6 times 3 minus 2 over 3 cubed, which is 2 over 27. Okay, so we end up with 18 minus 2 over 27, which is going to be 17 and 25/27, I think. 17 and 25/27.